day to our lecturer, Dr. Rashida Omar, and to all our viewers. We are from Group 3, and in this video presentation, we will present our findings on the fundamentals of logic for MAT210. Before we start, let me introduce our team members. Our team members consist of 3 members. The first one, we have Alpha Irtina. Second one, we have Nicole Alisa. And for myself, I am Nur Sharifa. In this video, we will break down the core principles of discrete mathematics and demonstrate their practical applications in solving logical problems.
My name is Nicole Alicia Mani. I'm going to start with slide introduction. Logical is a fundamental tool for reasoning and problem solving used in mathematics, computer science, and digital systems. It provides a framework to evaluate statements and simplify complex problems using logical connectives such as AND, OR, and NOT. This concept allows us to analyze patterns to tables to identify tautologies, contradiction, and contingency. Beyond theory, logical is the essential foundation for programming, digital circuit design, and database management. Now, I'm going to start for question 1. We are given a condition statement. The statement says if Farsa passes the examination, then her father will give her a special gift. This type of sentence is called an if-then statement in logic. So my answer for Roman is, first I assign symbol to each simple statement. I let P represent Varsha passes the examination and Q represent her father give her a special gift. My answer for 2 Roman, since the sentence is start with if and end with then, we use the implication symbol. So the symbol from P is applied to Q. A written has P equal to Q. Next, we're asking to find the inverse. So the inverse is formed by negating both of P and Q but keeping the same order. So my answer for the inverse, if Farsa does not pass the examination, then her father will not give a special gift. This is question 2. For question 2, we are given a compound logical statement, not in bracket P and R close bracket implies to not in bracket Q or R close bracket. To analyze this statement, we must construct a truth table. Now, my answer for that question, there are 3 variables, P, Q, and R. Since each variable can be true or false, we need to add arrow in the truth table. To avoid the confusion, I bracket the statement into smaller parts. I collect P and R first, then I negate it. After that, I calculate Q or R, then I negated it. An implication statement, it is only false when the first part is true and the second one part is false. In all other cases, the implication is true. To complicate the truth table, we can see that the final column contains with both true and false value. This means the statement is not always true and not always false. For the statement is classified has a contingency. Thank you, that's all from me.
Hello everyone, for my part in this presentation, I will be addressing question 3. We are tasked with analyzing the logical expression. So in this question, our logical expression is UNT or not U or not U and S. First, I will demonstrate how to draw the equivalent switching network, and then I will show how to simplify this expression using the laws of logic. In part A, we translate our symbolic expression into a physical switching network. As shown in my notes, a conjunction is represented by switches in series, meaning they are on the same line. This is why U and T are placed together on the top branch. This junction is represented by switches in parallel. The overall structure of our network consists of two main parallel paths. The top path handles the first part of our expression, while the bottom path represents the more complex nested bracket containing node U and the series pair of node U and S. Now, let's simplify the expression to see if we can create a more efficient circuit. For step 1, we look at the second half of the expression. By applying the absorption law, the term node U or node U and S simplifies directly to just node U. This is because the S term becomes redundant when paired with node U in this specific way. Next, we use the distributive law to expand U and T or node U. This gives us node U or U and node U or T. Now, we apply the inverse law. Since a variable or with its negation, node U or U is always true, we replace it with a tautology or T. Finally, by the identity law, any expression ended with T remains itself. Our final, most simplified form is node U or T. This tells us that a circuit with only two switches in parallel would function exactly the same as our original complex 5-switch network.
Hi, my name is Afar Irina binti Abdul Malik, and I'll be the one presenting question 4, A, B, and C. If Nurul does not read a book, then she will bake a cake. If Nurul goes to school, then she won't bake a cake. Nurul goes to school. Question A is to write three propositions using the variables P, Q, and R. We'll let P represent Nurul reads a book, Q will be Nurul bakes a cake, and R will be Nurul goes to school. Next is B, is to write all hypotheses and premises using the variables in A. Premise 1 is if Nurul does not read a book, then she will bake a cake. This is if not P, then Q. Premise 2, if Nurul goes to school, then she won't bake a cake. This becomes if R, then not Q. Then in premise 3, Nurul goes to school, which is simply R. Next is question 4C, using the rules of inference to find the conclusion of the argument. Step 1 is premise 1, which is if not P, then Q. Step 2 is the premise 2, which is if R, then not Q. And step 3 is the premise 3, which is R. And step 4, by applying modus ponens with step 2 and 3, we will get not Q. And step 5, by using step 1 and step 4 in modus tollens, we will get not P. And finally, by using double negation, we will get P. So the final conclusion is P, which is Nurul reads a book. In conclusion, this assignment helped us understand the basic concepts of discrete mathematics, especially logical connectives such as AND or NOT, conditional and biconditional. By applying these concepts to the given questions, we were able to analyze statements logically and determine their truth value correctly. This knowledge is important as it improves logical thinking and is useful in computer science, mathematics, and everyday problem solving.
So here is some of the reference that we use while doing this assignment. There are 3 references here. The first one is Brandy 2014 Agosto, and then the second one is Lakshmi R&D, and the third one is The Math Sorcerer 2020 October 7. So all these 3 references about the logical equivalence, it's give us more info about it, so it's really helped us. Actually, there are more website reference that we use, but this 3 is one of the most helpful website.
That is all from us, and we would like to say thank you for your time.